Okay, I haven't posted a video for a while, but the reason behind that is that I have been doing some very extensive memory testing with various Samsung B-die based memory kits on the Z490 Kingpin. And it all started when another local user here in Finland sent me this brand new memory kit to test on the Z490 Kingpin, and this particular memory kit is G.Skill TridentZ RGB 4400 MHz frequency with CAS16. So the timing table is 16, 19, 19, 39 at 1.5 volts. So this is a 2x8 GB memory kit. So these are single-sided memory sticks. And if you look carefully at the batch dating, you can easily note that the kit has been dated November of 2020. So this is a very new memory kit from G.Skill. So I was very interested to test this particular memory kit out and see how well it could do against my other Samsung B-die based memory kits. So honestly, if you look at the high frequency options from G.Skill right now, when talking about the single-sided memory kit options, so 2x8 GB options, the most interesting high frequency options from G.Skill are the 4400 CAS16, the 4600 CAS18, as well as the 4800 MHz CAS18. The problem with the 4600 as well as the 4800 MHz CAS18 kits is the price. The starting price of the 4800 MHz CAS18 is somewhere around like 400 euros and onwards, whereas you can get the 4400 CAS16 for as low as like under 200 euros. It all depends a lot on which heatsink type you want. The fancier the heatsink is, the higher the price. So if the more standard heatsink design is just fine for you, you can get the Ripjaws 5 for I think as low as like 170 euros and onwards. And the more fancier heatsink options like the RGB or the TridentZ Royal, I think that the starting price for those is somewhere around like 190 to 200 euros. So much lower than the 4800 MHz CAS18, like half the price. So that's why the 4400 CAS16 is definitely more attractive options for the wider audience compared to the 4600 CAS18 or the 4800 MHz CAS18. So I first tried this particular kit on the Z490 Kingpin with just the CPU on water cooling, like see how well it could do with daily type timings and so on, and I quickly found out that I just could not go anywhere beyond the very common like 4800 MHz frequency cap. The 4800 MHz daily profile, which is integrated in the Z490 Kingpin's BIOS, worked flawlessly with this particular memory kit from the get-go, but I just could not get the frequency any higher than the 4800 MHz level. So that kind of proves that the limit is not really on the memory kit itself, but on the actual CPU's memory controller. So it has been the same for a few generations right now. The frequency cap on these CPUs is somewhere around 4800 MHz with single-sided Samsung B-die based memory sticks when using the CPU on air or water cooling, I mean. So that's not really the most optimal way to test the real limits of the actual kits themselves. So I just wanted to step it up from the get-go, and I actually put the CPU directly on single-stage phase change cooling. So that is like a fridge attached to the CPU itself. That kind of a machine can hold the CPU temperature somewhere around like -62 to -64 degrees Celsius, when I was only using like 2 cores enabled without hyperthreading to keep the heat load at minimal levels. Because my particular unit is kind of old, it's not really designed for these modern high core count CPUs that really draw a lot of power. So my unit cannot really hold a 10900K with all cores and threads enabled in a multi-threaded workload like Cinebench and so on. But for memory testing, that kind of a unit is just all right, and it really serves the purpose even today in 2020. But that's really the only use scenario I would recommend anyone to use that kind of a device with these new CPUs, because these CPUs really draw a lot of power, and not to mention the X299 CPUs as well as the AMD Threadripper and the Intel 28 core Xeon. But when I put the CPU on phase change cooling and I just let it to cool down to -60 and colder, I could see the difference immediately. So the test what I haven't really run properly on this brand new platform is the very old and famous SuperPi 32M test. The Z490 Dark Kingpin has been proven for numerous times already that it has insanely good performance in the more modern like memory workloads like Geekbench memory score, 3D Mark, physics tests and so on. But I really wanted to try the memory sticks on SuperPi 32M, because that test is very hard on the memories, especially on the Samsung B-die based memory kits. And the G.Skill TridentZ RGB 4400 Cas16 could easily do 4800 MHz frequency with 14-14-14 and 14-13-13 timings with command rate 1 and with tight sub timings. So that's already a very good result, and with a voltage of like 1.95 volts. And that's pretty much in line with my other high-end single-sided kits that I have, like the Kingston HyperX Predator 4133 Cas19 as well as the Galax HOF OC Lab 4800 Cas19. The maximum frequency of the TridentZ RGB ended up being somewhere around like 4900 MHz and 4933 for SuperPi 32M with 14-14-14 timings and command rate 1 and with tight sub timings. TRCD and TRP at 13 really stop quickly after 4800 MHz, so it's really hard to maintain those at 13 when going up to like 4900 MHz and beyond. The most interesting part of the testing really happened with the Kingston HyperX kits. So I tested all of these kits on the Z490 Dark Kingpin once again when I was running the CPU on phase change cooling. I even tested the dual-sided memory sticks on the same board, although with the dual-sided sticks you are always limited to just command rate 2 only. Dual-sided technically has better performance in every possible situation when the performance figures are the same, so same frequency and same timings pretty much. But command rate 1 really helps in that old SuperPi 32M test, because command rate 1 allows you to go lower in round trip latencies for both of the memory channels, so the overall latency is much lower, and that really helps in that old and famous test. So that is why if you really want to make a competitive score in that old particular test, you need to have a very strong single-sided Samsung B-die based memory kit with A2 PCB. So the most interesting part of the testing really happened with the Kingston HyperX Predator 4133 Cas19 kit. And when looking at the memory options of today, the 4133 Cas19 doesn't really sound any kind of super stock setting. But when I purchased this almost 2 years ago, like in December of 2018, this was the highest option that was available from Kingston HyperX back then. And this particular kit is truly awesome on this particular motherboard, because it can post and boot the settings I wish to run like very easily. So let's say I want to run like 4900 MHz or 4933 with 14-14-14 timings, command rate 1, tight sub timings. I F10 save and exit, and it will instantly train the settings easily, and it can boot to the operating system. Whereas with the TridentZ RGB as well as with the Galax Hall of Fame sticks, it can sometimes take up to 5 minutes to post the desired settings, and that's really painful thing overall. Like imagine if you are running the CPU on LN2, you really have to consume a lot of LN2 and wait for the memories to train properly, because it will just do numerous like failures when it tries to drain the memory. So that's really annoying part, or really annoying feature of the TridentZ RGB sticks as well as the Galax Hall of Fame sticks. But I think that really depends on the actual memory sticks themselves. So even if these particular sticks from Kingston HyperX that I got might post settings very quickly, it doesn't guarantee that the next similar kit from Kingston HyperX that I purchase will have so fast booting as well. So the next kit I might buy from Kingston HyperX from some retail store, they might have a very slow trading process as well. But that was just a feature I found out quickly on the Kingston HyperX kit. And the maximum frequency for these sticks over here in SuperPi 32M ended up being 4933 megahertz with 14 timings and command rate 1. I could pass 4900 megahertz easily with the Kingston HyperX sticks, but the best combination ended up being one HyperX stick and one Hall of Fame stick. So the best combination was when I ran this particular Hall of Fame 4800 MHz Cas19 stick in the channel B and this particular stick in channel A. And that was able to run 4933 frequency numerous times over and over again. And the best score I got in SuperPi 32M was 5 minutes 50.703 seconds. The best ever 5 GHz Comet Lake run in SuperPi 32M at the time of making this video is done by Ralph from Sweden, and the score is 5 minutes 50.375 seconds. So that's like 325 or 28 seconds faster than what I got. So I think it's very good result by Ralph, and the main difference is that he is running much lower memory frequency but tighter timings. So he was running 4800 megahertz but with 14, 13 timings, and I think a little bit tighter sub timings. But the main difference, so if you really want to hear the honest difference between, let's say, the Maximus 12 Apex and the Z490 Dark Kingpin as Ralph was running the Maximus 12 Apex, is that the Maximus 12 Apex can run a little bit tighter RTL values, at least on air or water cooling. So it seems so that the Maximus 12 Apex can run 55 and 55 on both of the memory channels with a very good memory kit. Whereas with the Z490 Dark Kingpin, what I've been testing is that I'm usually stuck to just 57 to 58 RTL values when I ran the CPU on water cooling. So 57 RTL on channel A and 58 RTL value on channel B when the CPU was running on water cooling. And when I put the CPU on phase change cooling, I could drop the RTL values to 56 and 57 even when I ran the memory frequency up to 4933 and 5 gigahertz. And I think the lowest RTL value I got was 56 and with quite good IOL values as well. So maybe when I get the CPU even colder, like on LM2, maybe RTL 55 could be possible even on this buffer board. But that's the main difference between the Maximus 12 Apex and the Z490 Dark Kingpin. So the slightly better RTL, I think it helps a little bit in those very old tests. But there's also one downside that the Maximus 12 Apex has that's not present on the Z490 Dark Kingpin, and that's the actual base clock tuning. So on the Asus board, when you run these special overclocking buses that have the Spectre and Meltdown patches removed, you are pretty much always limited to just 100.0 base clock. So you cannot really move the base clock at all for the actual post process, nor you can really move it at all in the OS. So that's kind of limited if you ask me. But on the Z490 Dark Kingpin, you can easily post and boot various base clocks. Like I could easily drop the base clock down to like 98 or increase it to 104, 106 and run and post memory settings at that base clock. And I could easily move the base clock by quite a lot in the OS with an overclocking software. So that's very good part about the Z490 Kingpin, so that it's not that handicapped about base clock overclocking when using a special BIOS without the microcodes. So damn happy. So 4900 to 4933 frequency stable in 32M, and also the HyperX sticks, they could even do the Geekbench 3 memory test, or well, the overall Geekbench 3 test at 5 GHz at same timings what I ran in that SuperPi 32M run. 5000 MHz with 14, 14, 14 timings, and remember, command rate 1 with only 1.99 volts, 1.99 to 2.02 volts on the memory, 1.6 volts on the system agent, and 1.45 on the VCCIO. I could even post and boot 5066 MHz with these particular sticks, and remember, they were on air cooling for the whole testing. So none of these memory sticks ever saw any cold temperatures than just the ambient room temperature. Only the CPU was running at -60 to -65 between that, around that area. So 5000 plus with Samsung B-die sticks on air cooling, that's really insane result. So I could post and boot 5066 MHz on the HyperX sticks, but I couldn't run it stable in Geekbench 3 with command rate 1. I could pass the test once with command rate 2, but it blue screened after the test, like shortly after the test, but the score was kind of bad. It was actually below what I got with command rate 1. So when I ran Geekbench 3 with command rate 1 at 5 GHz, I got a memory score of 10,279, which is kind of good if you ask me. And if I put the memory sticks on LN2, the frequency would go much higher. So the negative part about the TridentZ RGB as well as the Galax Hall of Fame OC Lab sticks is the very slow post process. So even when I mixed one of the HyperX sticks with one of the Galax sticks, the whole post process was very slow. So when I tried to post, let's say 4933 with 14, 14, 14 timings and command rate 1, it could sometimes take up to like 2 minutes to post the settings successfully. So that's really annoying part about those memory sticks. So if I had to recommend like any of these memory kits for your own build, so if you want to do, let's say, overclocking on the Intel Z490 platform, or even on the AMD platform with Ryzen 5000 series CPUs, of course I would recommend you to get some of these new dual-sided memory kits, because with these you can get higher capacity, like 32 GB instead of 16, and you have better performance, and command rate 1 is not really needed when talking about daily use. So the most optimal bins from, let's say, G.Skill are the 4000 Cas16 and the 4266 Cas17 when talking about the 16x2 memory kits. But really, the Kingston HyperX Predator 4133 Cas19 really performed well. So these are really good if you only need, let's say, 2x8 GB for your system. 16 GB is kind of low in today's standards, but this color scheme really suits well with the Z490 Kingpin. So those are the results, very good results in SuperPi 32M as well as in Geekbench 3. And now it would be very cool to try to make a very competitive score in SuperPi 32M overall, but that requires a very good CPU, and I don't have one at the moment, but I might have one soon, like very soon. So I will keep you updated that if I get some new parts soon and what we will be doing next. So if you have any questions or comments about these particular memory kits, or about Samsung B-die overclocking on this particular motherboard or on this platform overall, then drop a comment down below and I will try to answer them. But overall, the memory overclocking is very hard with these newer platforms. It really takes a lot of time and a lot of attempts. I tested like 15 different Windows XP operating systems while trying to get better performance to get the best possible run in that particular test. But I think 5 minutes 50.7 seconds is quite good result overall. And I will just have to see if I can do a better score later. So thanks for watching. If you like to see this video, although this was kind of boring one, only just me talking about my own stuff, but that's what it is. Easier to do this this way than film those countless attempts in Super 32M. But yeah, so thanks for watching, and I will see you on the next one.